Hi students, in this video we will be going over parallel and perpendicular lines. Our essential question for today is, how are parallel and perpendicular lines written given equations in slope-intercept form? So one more time, how are parallel and perpendicular lines written given equations in slope-intercept form? So first let's go over a couple of definitions that are important for us in this lesson. So parallel lines are two lines that will never meet. And they would look something like this. You can see that if those two lines were to extend on forever, they would never cross. And perpendicular lines are kind of like the opposite. They are two lines that directly form a 90-degree angle. So they do cross, but they form an exact angle of 90 degrees. So if there's an angle of 90 degrees here, then every single angle would also be 90 degrees. Because when you go around a graph, that's 360 degrees, so each one would form 90. So again, we've got parallel lines, which are lines that never meet, and perpendicular lines, which are lines that meet, but form exactly a 90-degree angle. Now, what we're going to be going over today is how do we create equations based upon a parallel or a perpendicular slope. And for instance, let's say that you've got an equation that is y equals x plus 2. What if I wanted to write a line, create another line that was parallel to it, and how would I find that, and how would I write it? Same thing with perpendicular. So first let's talk about how do I find the slope of parallel or perpendicular lines. Now parallel lines are so easy because it is the exact same. And think about that. If you were to draw on a graph a line, so let's just say that you've got a line that goes across like this, then obviously if your slope is, let's say your slope is, I don't know, 1. If I wanted to find the same slope for a parallel line, it would also be 1. They would both have to have a slope of 1 going in that same direction so that they never cross. So if you're looking at equations of the line and you're trying to find the parallel slope, all you have to do is write down the same slope that you had before. So for instance, if the slope is 6, then the parallel slope will be 6. If the slope was negative 1/2, then the parallel slope will also be negative 1/2. It's very simple. Now perpendicular lines are a little bit different. And think about it, because if you were to draw a line, so let's say that we've got our original line, and we wanted to create a line that crosses it, it's almost like it has the opposite slope, because it's going across in the opposite direction. And if this was a positive slope originally, then this one will become a negative slope. Now the rule for this is that you flip the slope, okay? So you find the inverse, and you change the sign. Okay, and when you find the slope of this, you find the inverse of 3, and the inverse of 3 is 1/3, and then you change the sign to a negative 1/3. Now on this one, we've got negative 1/4, so we're going to change it to its inverse and change the sign. So instead of negative 1/4, it's going to just be 4. So we flipped it, and we changed the sign. Now take a moment and practice these problems and see if you can find the slope of the parallel lines and the perpendicular lines. Now let's talk about writing equations for these parallel or perpendicular lines. And the steps for this, if you remember writing equations, what we've been working on over the last couple weeks, you're going to see that it's a very similar process, and which makes this very easy. So our first step is to find the slope of the parallel or the perpendicular line. Then you're going to take the points that you've been given and substitute it into the equation to solve for b, which is our y-intercept. And then last, like we've done every single time we've written our equations, we then put in the slope, and we substitute in the slope and the y-intercept into the slope-intercept form. So I know this is very wordy right now. It's important to write it down. But once you start seeing the examples, I think you'll see how similar it is to what we've already been doing and how easy it is. Okay, so example number 1. We have got a point, and we're trying to find a parallel line that goes through the points 2 and negative 4. but is parallel to the line y equals 3x plus 2. So our first step is to find the slope of the parallel or perpendicular line. Now, if you remember when you do the parallel lines, it's very simple because it's exactly the same. So what would our parallel line be when it's y equals 3x plus 2? Well, it would just be 3. So we know that our original slope was 3, which means our new slope is also going to be 3. So we found our slope, which means we've done step number 1. Now let's talk about finding our y-intercept. Now this is where it's going to look very familiar to you from what we've been doing. We've got our slope-intercept form, and we just found out that the new slope is going to be 3, which is still the same slope. So we're just going to put 3 into the place of the slope. But now we have to find out what's the y-intercept because it's not going to be the same as it was before, or they'd be the exact same line. So what we are going to do is take these 2 points and plug them into x and plug them into y, just like we did on our previous set of practice and notes and activities and projects. So 3 times 2 then is 6, and then we solve the equation, and by moving 6 to the opposite side, it becomes a negative 6, and we get negative 10 equals b, so that is our y-intercept. Our last step is just to write our equation. So we take our slope-intercept form, we plug in our slope and our y-intercept. It's always helpful to put them in parentheses first. That way you make sure your signs are right, especially with the y-intercept. And then we find out that our slope of the line is y equals 3x minus 10. Now, if you were to imagine this on a graph, what you would end up having is you would have a line. So let's say that you've got a graph. You would have like 3x plus 2 might be here crossing through the 2 on the y-intercept. But the negative 10, it would be lower down here where the negative 10 is on the y-intercept. So they would have the same slope. They'd be going in the same direction, but they're starting at or crossing at different points. All right, now take a moment and practice that problem that is on your foldable, I believe, and insert your answer into a puzzle. All right, let's look at another example, but this time we're going to talk about one that is a perpendicular line. So we want to find another line that is perpendicular to y equals 1 over 8x plus 2, but it goes through those specific points of 1 and negative 5. Now we know our original slope is 1 over 8. So to find our new slope, we need to flip that. So we need to find the inverse and change the sign. So 1 over 8, the inverse of that would be 8 over 1, which is just 8. And since it's a positive, we're going to change it to a negative. So our new slope is simply negative 8. So we've got our slope. And our next step is to find our y-intercept. Now we know we've got to use our slope-intercept form, and that we're going to plug in our new slope into m, and that was negative 8. But to find our new points, what we're going to do is take x and y and plug them into that equation. So we've got 1 and negative 5, and 1 is going to go into x, and negative 5 is going to go into the y. So negative 8 times 1 is negative 8 still. And when we move the negative 8 to the other side, it becomes a positive 8. So now we have 3 equals b. So our y-intercept is b. And our final step is very simply just to write it. We take our slope and we take our y-intercept and we plug it in. So the negative 8 will go into the m, which is our slope, and the 3 will go into the b, which is our y-intercept. And we get our equation as y equals negative 8x plus 3. Now, if you were to imagine this on a graph, if you were to graph the very first one, you would see that it's at 2, but kind of has a, since it's a fraction, it has a flatter slope, I guess, for lack of a better word. But when we do our other one, it's going to cross over here, and it's going to have, that was actually a super terrible example, but it's going to end up having a steeper slope. Okay, so actually this line should have been more like that a little bit, except I'm not crossing it at the right place. When you don't have graph paper, it doesn't work out as easily. But the idea is that those two lines, once they are, if you were to put them on a graph, they would cross, and they would form exactly a 90-degree angle. Okay, so you've got another practice problem to try right here, so take a moment and practice that. And you have a few more practice problems on your foldable to try, but they're pretty quick, and this is an easy set of notes. But if you have any questions, let me know, and we can go over those in class, or I can answer them via email. All right, have a good day.